I'd like to go over a few quick housekeeping notes. All of our participants today are in listen-only mode. You can select mic and speakers to join using your computer, or you can use a telephone to join, and there's some instructions on your screen regarding that. A very important note, please submit your questions throughout the webinar as you think of them. You can do that by typing them into the question box on your webinar console and hitting send. We will queue up all of your questions and answer them as time allows at the end of our presentation today. So please do type your questions in as you think of them and don't save them to the end. And a final note, this webinar is being recorded. You will find a copy of this recording as well as all of our previous webinars archived on our website at cisa.org/webinars. With that, I'd like to pass this over to Val Story. Val?
Thanks, Sam. Hello, everyone. Thanks for joining today's webinar. We have an exciting and thorough presentation waiting for you today, so I'll be brief. I wanted to introduce the Clean Energy States Alliance, otherwise known as CISA, to you. CISA is a national nonprofit group that works with state and municipal clean energy funds and state agencies to promote renewable energy markets and technologies. We tackle policy, finance, and innovation strategies in energy generation, and we focus on collaboration and information sharing with our state members. And we also offer client services such as technical assistance. And we work to support multi-state projects and partnerships that address major renewable energy policy issues that impact renewable energy markets and investments. We have state members from across the country. That's the next slide, Sam. Thank you. And most of them, as well as CISA, we've mainly been working on issues related to energy generation, including grid resiliency and energy storage. But more recently, we have moved and expanded our programs due to member interest to focus on renewable thermal as well. Next slide. As you'll learn more in today's presentation, heating and cooling energy use in the U.S. is the third element in the U.S. energy picture. Heating and cooling account for about 44% of energy consumption in the U.S. directly. That's in the residential, commercial, and industrial sector. It's used in every building space, from homes to warehouses to manufacturing facilities. And so, due to member interest, CISA now has a new renewable thermal program. It's pretty new, but we are focusing on 4 technologies: air source heat pumps, ground source heat pumps, woody biomass, and solar thermal. And together with our state members, we're seeking to address efficiency and emissions concerns. We're addressing testing protocols and standards and trying to come up with some best practices for programs. We've identified several common challenges, including in biomass, the issue of thermal storage and its impact on efficiency and emissions. And we are working, we've identified the lack of performance data, monitoring and metering, the lack of standards, and financing as some common challenges which we can address together. Next slide. Today's guest speaker is Neil Veilleux. Neil is a director at Meister Consulting Group, where he leads the firm's renewable thermal and other clean energy initiatives. He regularly works with U.S. and international clients, including the United Nations Environmental Program, Massachusetts Clean Energy Center, IEA, RETD, the Minnesota Department of Commerce, the City of Boston, New York City, and currently working with CISA as well. He recently completed an international study on next-generation renewable heating and cooling policies on behalf of the 8 countries that make up the IEA, Renewable Energy Technology Deployment Implementing Agreement. Before joining Meisters, Mr. Veilleux managed warehouse operations for a major industrial supply distributor. He also served as a Rappaport Public Policy Fellow at Harvard's Kennedy School of Government. He was a Fulbright Scholar in Germany and a Renewable Energy Fellow for the Heinrich Böll Foundation. His presentation is up next. You'll learn more about this recent renewable heating and cooling paper that he recently authored. Neil, thank you for being with us.
Hey, thanks so much, Val, and it's good to be here. So as quick background, Meister Consultants Group, we've been working in renewable heating and cooling policy for about 8 years now. It initially started when one of my colleagues wrote one of the first, if not the first, paper on renewable heating and cooling policy in the U.S. For an academic journal. In the process, we spoke with a number of trade groups about where they saw the renewable heating sector going. We spoke with policymakers, including folks in Massachusetts, and ultimately found that the U.S. really wasn't addressing this sector at that time. It was in stark opposition to what we were seeing happening in Europe as well. So Europe had for several years at that time been sort of thinking about renewable heating and cooling policy and recognizing that they needed to address the heating and cooling sector in order to meet their energy and climate goals. And as a result, the renewable thermal sector was really the missing piece of climate policy in the U.S. And in the intervening years, we've connected with a number of U.S. policymakers and some of those industry stakeholders and a whole host of other stakeholders to sort of look at how we can encourage growth of the renewable thermal market in a way that makes sense for policymakers to meet their energy, climate, and economic goals. So out of that work, more recently, we got in contact with the International Energy Agency and the 8 countries that they were working with through IEA RETD. And these countries are mostly in Europe, but also including Japan and Canada, had an interest in some of the next generation policies. Many of these European countries had sort of done some basic work on renewable heat, seen some modest market growth, but we're looking at sort of what can we do next to really stimulate the market to see it grow in a logical, responsible way. And so that's where this report came from, Waking the Sleeping Giant, looking at next generation policy instruments that could be applied to renewable heat. Let's see.
Click on the screen to activate the mouse control there.
I mean, if you could advance the slide for me, we'll keep on going. So for today, we'll look at sort of 4 key elements. Just a quick introduction to renewable heating and cooling, a brief look at what's going on in the Northeast today, next generation policy options. So really, what did we look at in particular for this IEA study? And then we welcome your sort of questions or comments. So on the next slide, you'll see can we advance to the next slide?
Sorry, there's a bit of a delay.
So what is renewable heating in comparison to conventional generation, which is primarily fossil fuels? You have things like coal, heating oil, natural gas, propane, and electric resistance. Renewable heat comes from renewable resources, and no jurisdiction really has the same definition. We see a number of different definitions across jurisdictions, but it may include things like solar thermal, geothermal, which could be geothermal heat pumps, both air source or ground source heat pumps, sustainable biomass. Some jurisdictions include anaerobic digestion, so biogas, and others include combined heat and power. A variety of applications may be used here as well. Typically, renewable heat can be used for space heating and cooling, or hot water, or process heat. Similarly, it can be used in residential, commercial, or industrial sector. And I think most interestingly, there's a question of what's the distribution of the heat. And is it for an on-site unit, sort of directly in a building, or is it part of a larger district heating network? And this is sort of a key difference and influences a lot of the policy decisions as well. But a key difference to renewable electricity technologies like solar PV, right? So in solar PV's case, you can build the array on a building, sort of feed the load in the building, but also net meter back to the grid. For district heating, the majority of systems that we see for renewable heating are sort of building integrated, so they have to be sized and installed to serve the building load, sort of like an energy efficiency technology. However, there is the option to integrate it into a district heating grid, and in fact we see a number of European countries and some U.S. jurisdictions as well integrating renewable heat into a district heating grid. And so you do have this option for sort of advanced tariff or metering structures where you could effectively net meter heat back into a district heating grid. But we'll get some of that more later, and keep charging on to the next slide. There we go. So the heating sector is the largest energy user across the globe. And this chart here breaks down energy use by sector for the electricity, transport, and heating sector. And now, so estimates vary depending on sources, but this was based on an IEA analysis of final energy use. And you can see by far heating makes up 40 to 50% of total energy use, much greater than electricity or the transport sector. Now, within that, the building sector makes up about a third or maybe a half of total energy use. Industry makes up another big portion, and then there's others sector within the heating sector that is just sort of other uses. So for this study, we focused primarily on building energy heat. So within the building heating sector, you can see that buildings are primarily heated with fossil fuels, so natural gas, oil, coal making up the majority of energy use. There's also globally sort of a large chunk of traditional biomass, which doesn't typically get included in the renewable heat category, primarily because this traditional biomass tends to be sort of high polluting biomass appliances. So a lot of particulate matter emissions coming from there. However, we do see, especially in Europe and here in New England, more and more sort of modern biomass systems coming online. And so these are high efficiency, low emission systems. Again, estimates vary, but roughly you can assume about 10% of global building heating use comes from modern biomass. And then there's sort of other technologies that could be renewable heat, making up about 1%. Now, in sort of looking at any of this data, it's important to keep in mind that there's really limited data, limited metrics on global renewable heating and cooling markets. It's sort of very difficult to measure, and it hasn't been done very well. IEA has a few studies out there that we've reviewed, but this is sort of the best snapshot that I think is currently available on building heating use globally. So in the course of the study, we also looked at market development for the IEA RETD countries. And when we sort of assessed market development, we broke the market up into sort of three main phases: the inception phase, the takeoff phase, and the consolidation phase. So the inception phase is really sort of early stage markets. And you'll see here that countries like the United Kingdom or Ireland really have about 2 to 5% of total heating cooling market share in those countries. Sort of early stage markets, relatively small markets for renewable heat. However, it's also worth noting that these countries, UK and Ireland, have some fairly aggressive projections for the development of the renewable heat market, looking to get to 2020, 12% by 2020, and some good policies to back that up. You have other countries like Germany and France, which are sort of in the late inception or sort of early takeoff stage of the market. So about 12 to 17% of total market share today, looking to increase that to 16 and 33% respectively. And then you have other countries like Denmark and Norway, which are the more mature renewable heating markets out there, sort of with market share in the mid to high 30% range, and looking to increase that to 40% or more by 2020. And many of these countries even have longer-term goals to 2050 where they're looking to get quite aggressive, even up to 100% of market share. But these are sort of the clear leaders, Denmark and Norway, as far as renewable thermal market grows. There's a whole series of countries like Japan and Canada where there's just not great data, right? And the assumption there is that they have very, very small renewable thermal markets. We would generally include the U.S. in sort of this category with Japan and Canada, where we expect that the total market share is probably sort of in the very, very low. I'd say less than 5%, probably less than 2%, but it's not really clear. But certainly they're in the inception stage. In part, this is because there's been a historic lack of innovation and commitment to renewable heating and cooling policy, especially compared to renewable electricity markets like wind or solar. But it's becoming increasingly clear that to many policymakers that they really have to move the renewable thermal market along this market development curve in order to achieve their energy and climate goals. So a takeaway of the report, sort of IEA's general takeaway on this report was that a renewable heating transformation is necessary to achieve energy, climate, and economic goals. And in considering these goals, policymakers pointed out sort of two general approaches they take to looking at it. One is sort of their big picture macroeconomic objectives, like climate mitigation, climate adaptation, sort of increasing energy security. For example, many European countries are very concerned about natural gas reliance and the geopolitical impacts of getting natural gas from Russia. So how can they sort of encourage homegrown renewable thermal markets that can improve their energy security and also increase their economic development? On the other hand, there's a number of goals that consumers tend to be very interested in. Can they achieve cost savings from renewable thermal technologies? Oftentimes that depends on the policy structure in place and whether the economics work out. But many of the technologies can increase building comfort along with energy efficiency, provide some price stability or hedging benefits, and then generally just the green leadership and responsibility goals that a lot of consumers or corporations will have. So that's sort of big picture of what the renewable heating and cooling market is and why some policymakers care about it. But let's take a closer look at the northeastern markets and policies. So we looked at policies in New England primarily, just to sort of give an overview, sort of a sampling of what some state policymakers are doing for this presentation. So Massachusetts, for example, we've had the pleasure of working with Massachusetts for a number of years on their renewable heating and cooling policy, and really enjoy talking about them. I think they've been doing great work. They've developed a comprehensive renewable thermal roadmap, the Commonwealth Accelerated Renewable Thermal Strategy. This really lays out the next steps and programs and policies that they expect to see over the next several years to grow the renewable thermal market. Similarly, DOER is working on regulations to integrate renewable heat into the alternative portfolio standard, which is like an RPS, utility mandate for alternative technologies, right? So not solar or wind, but the APS covers things like flywheels and CHP, and soon to be incorporated will be a number of renewable heating technologies. And then Mass DEC is also running a number of pilot programs for biomass, ground source heat pumps, air source heat pumps, and the solar hot water program. Maine has a very high percentage of oil heat use. About 80% of households in Maine use oil heat. And the state's established a number of oil reduction targets, specifically 30% by 2030, 50% by 2050. Efficiency Maine's providing a number of incentives and financing for technologies as well. New Hampshire has developed the first carve-out for renewable thermal, the first in the nation, as part of its renewable portfolio standard. They are now accepting applications and sort of did a lot of work to figure out the heat metering requirements for that RPS carve-out. This is an interesting program in that it is a performance-based incentive for heat, which we'll talk about a little bit more later. They do have solar hot water rebate, though last time we checked in with them, there was relatively little demand for it. And the residential and commercial industrial wood pellet boiler programs are quite popular. Vermont has established a goal to obtain 90% of energy from renewables by 2050. This would, in theory, necessitate the use of renewable heat and a bit of a focus on biomass and ground source heat pumps. The Vermont governor also signed an MOU several years ago with Upper Austria, which is a state in Austria that has a very strong renewable thermal cluster, in particular to promote biomass heating in Vermont. Connecticut has got a little bit of activity going on, but not a whole lot. CFIA and DEEP are supporting deployment of CHP and anaerobic digestion in the state. Some of the technologies, solar, water, and ground source heat pumps can receive financing, but there's not, at least when we last checked in May, any current incentive programs available. Some interest in metering and the RPS thermal provisions as well. Similarly, in Rhode Island, policymakers there tell us that renewable heat's on the agenda, but we haven't seen a whole lot of activity yet. The utilities are evaluating some opportunities for air source heat pumps. So yeah, this is just a sampling of what we see going on in some of the northeastern states. I'd be remiss not to point out that there's a number of other states that are quite active in the renewable thermal market, but can't cover them all here today. So looking a little bit closer at Massachusetts, we've seen sort of market development take an interesting path in Massachusetts and really getting kicked off for renewable heat with the Renewable Heating and Cooling Opportunities and Impact Study, which was commissioned several years ago. We had, again, sort of the pleasure of working with MassCC on that study. As far as we know, it's the first integrated renewable heating and cooling technology and market assessment for a state agency in the U.S. And it was really just a baseline study of what are the technologies, what are sort of the economics for those technologies, and sort of ballpark climate impacts of renewable thermal technologies. So once MassCC and DOER had sort of a baseline of sort of how to think about these technologies, they ran a few pilot programs, and eventually the legislature asked them to conduct a study of heating and cooling for the Massachusetts Alternative Portfolio Standard. As I mentioned before, that's effectively a mandate on utilities and provides a performance incentive for technologies, these alternative technologies in the APS. And so the question that the legislature put to us was sort of what's the potential for integrating renewable heat into the APS, and could the utilities sort of effectively meet their goals by doing it? So we conducted a detailed LCOE analysis, a levelized cost of energy assessment on the technologies. We also looked at sort of various ways that the policy might play out. And so DOER ultimately got authority to integrate renewable heat into the APS, and currently they're working on the regulations for that policy to roll out. And so then following that study, that work, DOER asked to create sort of a comprehensive roadmap for renewable heat. So thus emerged the Commonwealth Accelerated Renewable Thermal Strategy. In this case, we worked with DOER to engage a wide variety of stakeholders, industry leaders, advocates, building owners, environmental nonprofits, obviously government leaders, to create this comprehensive roadmap. We also looked at international policy best practices and developed something like 120 potential recommendations, which were then prioritized by our stakeholder advisory group for more focused, I think it was about 20 sort of focused recommendations that emerged out of that study. And DOER, with its partner MassCEC is sort of now busy implementing a number of those strategies to sort of help transform the market. So out of these market transformation programs, you actually see today, and over the past several years, a fairly significant investment from Massachusetts. So starting in 2012, the state invested about $10 million in the Commonwealth Solar Hot Water Program, another $3.5 million in 2014 for renewable thermal business investment grants. I've linked up with the utilities. We're providing up to $500 rebate on air source heat pumps. In 2014, another $6.3 million came out through MassCEC for rebates for residential and commercial systems. And then there's 0% financing through the heat loan as well. Excuse me. I'd be remiss not to point out that I actually talked to folks at DOER yesterday, and I think there's another $7 million or so, maybe more, that is not accounted for on the slide, but this gives you a good sort of sample of the types of programs that Massachusetts has been rolling out over the last several years to help the market grow. It'll be interesting to see, too, what happens with the new APS regulations. This can be a real game changer and expected to stimulate somewhere between $550 to $990 million in private and public sector investment in the renewable thermal market. Great, so let's take a look now at some of the next generation policies and really what's happening on the international stage, or what could happen on the international stage. So next generation policies are new and innovative and have the potential to drive market development across the deployment curve. Excuse me, from the early stage inception markets right along to those mature consolidated market phases. As we defined it, next generation policies really could address one or more market barriers, enable large-scale, cost-effective, and mainstream deployment, and encourage improvements in product cost, efficiency, and reliability. So we broke next generation policies down into about 5 different types, from planning and targets to mandates, performance-based incentives, soft cost reductions, and innovative financing. And so what we've seen many of these policies in renewable electric markets for like solar or wind, but we haven't seen that many in renewable thermal markets. So a key recommendation was just to deploy lessons learned that we've seen from other sectors into the renewable heating and cooling market. So for planning and targets, things like develop a long-term plan for renewable heat. Massachusetts certainly has taken a leadership position there. A number of European countries have, but many do not have a plan at all for renewable heating technologies. And then similarly, refine and update that plan as needed. For mandates, really 2 types of mandates we were thinking about. One is utility mandates. So things like the RPS or other types of utility mandates, mandates for public buildings and new construction, and mandates for all buildings. And you'll note that this chart really lays out where we think some of these policies are best suited for inception stage, takeoff stage, or consolidation phase. So certainly our interviews and research suggest that perhaps not the best practice to deploy a mandate for all buildings, especially if the technology is or the market's really in the inception phase. In such cases, maybe a public building or new construction mandate would make the most sense. However, all buildings, we see some jurisdictions moving in that direction. An all building mandate for solar hot water, say, or air source heat pumps could be suitable in the takeoff or consolidation phase. We see some jurisdictions emerging with pilot performance-based incentive standards as well as metering standards. So another recommendation is to look at those incentives over time, refine them downwards and as a digression mechanism. And then also explore development for new tariff and regulatory frameworks, especially for district heating. And so in some cases, for example, we've seen solar hot water integrated into district heating networks, which can meter both to the building and back to the grid. Pretty innovative stuff emerging. Soft cost reductions turning out to be a pretty important area. In many cases, it's just not clear what the cost structure for renewable thermal technologies look like. So how much of it is based on the equipment cost, how much of the total cost is based on equipment cost versus how much is based on marketing and customer acquisition or permitting, or what's the cost associated with labor and installation. Sort of having a better understanding of that cost breakdown could help policymakers devise the right kinds of policies. From our interviews and our preliminary research, though, it's pretty clear that there's a need for local permitting and customer acquisition programs to help drive down the cost of renewable heating technologies. And then we just saw sort of enormous potential for a variety of innovative financing programs, from lender and contractor education to standardization of systems to encourage aggregation and ultimately securitization, and just incentives and programs that can reduce development costs along the way. So this is the general structure of the policies and programs, the next generation policies and programs that could be deployed to support renewable heating technologies as laid out for this IEA study. But let's take a closer look at some of these now. So with regard to planning and targets, from our research, there's only about 17 countries that have developed formal targets for renewable heat. And most of these are focused on only one or two technology, for example, solar hot water. So these are these countries in orange that have some sort of solar hot water or other technology target. There's only two countries that we know that have broader renewable heating and cooling targets. So we're looking at the sector as a whole, and that's Thailand and Germany. Now, it is worth pointing out that a number of EU countries have developed projections as part of their energy planning process for renewable heat in the EU. We didn't include those as formal targets, though some commentators do. If we did, we could sort of add in a number of the EU countries as well. As far as mandates go, this is a sampling of some of the mandates that we've seen across the globe. So it's worth noting that Massachusetts and New Hampshire, for example, are examples of jurisdictions with a utility mandate, namely integrating renewable thermal into the RPS, the mandate for the utility programs. A number of countries have building mandates as well, again, primarily for solar thermal. So Albania and Jordan, Germany, for example, has it for solar thermal, biomass, and geothermal. And so we did a quick survey of those countries across the globe. Moving on to performance-based incentives. The UK has its renewable heat incentive, which is perhaps the most famous performance-based incentive for renewable heat. And the RHI provides a set tariff to residential, commercial, public, and industrial consumers for every unit of renewable heat generated on a pence per kilowatt hour basis, right? So if you install a biomass heating system in your building, the RHI will pay you a set amount of for every kilowatt hour thermal that your system produces. In some respects, it's similar to a feed-in tariff in that it's a contract and a clear payment, though of course it's not feeding back into a grid necessarily. This chart actually shows sort of the number of applications and the cumulative installed capacity of renewable heat under the RHI from November 2011 to November 2014. So turning to soft costs, As I mentioned before, this is a pretty significant barrier to adoption, and there's really been no comprehensive analysis that we've seen on soft cost for renewable heating and cooling technologies. Several years ago, we did run a preliminary analysis for New York City in its solar water heating roadmap, trying to estimate the soft costs for solar hot water in the city. Now, this is a really special case where actually solar hot water is quite expensive, estimated at about $19,000 for a residential system. And looking at that, it was estimated about $6,500 of that cost consisted of the hardware, $6,300 for installation, $6,300 for permitting and inspection, and about $500 for other soft costs. It's worth noting this was limited on based on a couple of installer interviews, but it was sort of interesting in sort of thinking about where are the costs for these systems coming from. So sort of just knocking down the permitting and inspection cost, other soft costs, and installation costs could be fairly significant in bringing down the total cost of the system. Again, sort of outside New York City, we see solar hot water costs, total cost about half this. Similarly, in Massachusetts, we're seeing residential systems at around $8,000 or so. But sort of the overall sense of how much of this system is hardware versus soft costs is sort of an interesting question, and would sort of raise some potential for different types of policies depending on how we're trying to reduce the cost of this overall system. So looking at innovative financing as well, this is another area that we see potential, significant potential for development. And a number of companies are sort of taking a lead here in the U.S. We see some of this in Europe as well. But sort of turnkey developers can provide building owners with a range of renewable heating and cooling services, and third-party ownership in particular as a strategy to reduce the risk, hassle, and operational risk of renewable heating and cooling. So a number of companies in New England are beginning to explore heat as a service for renewable heating technologies. You have folks like Pelletco who are running with this model. You also have folks like New England Solar Hot Water who have sort of deployed a third-party ownership model in a number of projects. But sort of taking that hassle off the customer of having to understand how renewable heat works, or having to maintain it, or having to finance it, and providing just BTUs of heat to the end user and having them pay directly for that instead of the actual installation itself. So looking at the last slide here, I've really got thinking about what's a potential future for renewable heat in the overall energy strategy. And in Bornholm, Denmark, they've been piloting a pretty interesting system where they've integrated the heating grid and the electricity grid. And so they're using biogas, CHP, and district heat, and using them to balance one another so that CHP or biogas, for example, produces electricity. The waste heat is also used in the heating grid, and the district heating plant sort of scaling up as needed to provide supplemental heat. This approach also lets them integrate greater amounts of intermittent renewables like wind or PV. For example, a lot of offshore wind in Denmark that's feeding into the grid. And so when they sort of feed that energy in the grid, they can back down the CHP or the biogas plant, or they can store that electricity, right, in sort of electrochemical sort of battery storage, or they can transform it into heat and store it in ground source heat pumps, right? And so it's a very interesting system where they can sort of balance both the electricity and the heating grids by integrating the strengths of renewables as well as renewable heat and district heating. The end result is they just want to deliver heat and power reliably to end users, but also do it in a renewable manner. So there's a number of policymakers in Europe who are sort of watching experiments like this in Denmark quite closely and thinking about what's the role of heat in sort of the total grid development, sort of heat and electric grid development in order to sustain a renewable future. With that, I'll pause, and Val, turn it back over to you and sort of welcome any questions or comments.
Great. Thank you, Neil. Just a reminder to those of you listening, you can type in questions. There's a question dialog box on your screen console. It's probably on the lower to mid right of your screen. But we've got a few to address here. So, Neil, just actually, do you know if the mass study that you mentioned earlier, the roadmap and the residential the renewable energy heating and cooling analysis is publicly available?
It is all available on the DOER website. Mass CEC also hosts them on the website as well.
Okay, great. Thank you. You reviewed a few next generation policies and different financial support that could drive the deployment to the mature market phases. Are there ones that you think are better than others that would better support, or is it a mix?
That's a great question, and I think it really depends on the needs of the specific renewable thermal technology as well as the jurisdiction you're operating in. And so there's not sort of a one-size-fits-all answer that we can ever provide. Some jurisdictions, for example, we looked at New York City, right? And again, sort of noting that analysis was very preliminary, it was a pretty interesting indicator that permitting costs in New York City were so high. And so focusing on sort of reducing those permitting costs could make a pretty big difference. On the other hand, other jurisdictions might need to focus on just getting a foothold in the marketplace and some basic rebate or pilot program to do that. And then later stage markets might not want to sort of continue to invest in a rebate program, but instead sort of spread out the payments through a performance-based incentive program. So it really depends on what's the stage of market development and what are the needs of the mix of technologies that any jurisdiction wants to encourage.
Great, thank you. Clarification on that earlier question, Neil. The participant was asking about the levelized cost of energy analysis you mentioned. Do you know if that's also on the DOER site?
Oh, yeah, definitely. It's all publicly available. Yep.
Great, thank you. So you covered several countries in Europe that have a good level of penetration of renewable heating technologies. What drove market development in Europe? Is it country specific? Was there an overall EU directive, long-term targets, or is it varied?
Yeah, no, again, it varies. So you see some of the northern European countries like Denmark have taken a stand on renewable heat for many years. Austria is another good example. Austria's got a very long-standing biomass, thermal, and solar hot water rebate. I think they've had it in place since the 1980s. In Austria's case, they actually really focus on it as an economic development approach. This is Upper Austria, an economic development approach initially for farmers. And that really enabled them to gain a lot of political traction. In other jurisdictions like the UK, it's only very recently that they've turned their attention to renewable heat. They've been looking for cost-effective approaches to meet their climate and energy goals. In that case, they focused very much so on initially displacing oil, which is sort of the most cost-effective option for them. So it really depends. I should note, too, that several years ago there was a move to try to create a specific target at the EU level for renewable heat. Ultimately, that got subsumed into the broader renewable energy target under one of the EU directives. But that's also been sort of an important driver, I think, for many European countries to at least pay attention to heat as a sector to address their renewable energy and climate goals.
Great, thank you. Could you talk a little bit about strategies for the industrial sector versus the commercial or residential sector? We have a question here. If you could identify strategies that are specifically needed and successful for the commercial sector as opposed to the public or residential sector.
So I sort of heard two questions there. One was around what are strategies for the industrial sector. The second was what are the strategies for the commercial sector. Maybe it was three questions. And then what are strategies for the residential sector?
Yeah, just if there are very different ones for each sector.
Yeah, so good question. I'd have to just sort of defer on the industrial sector. It's a pretty complex sector. With a lot of sort of custom uses of renewable heat or heat in general. And so I haven't looked very closely at industrial sector strategies. I would welcome the chance to sort of explore it with anybody should they like to. On the commercial side, there's many parallels between what we sort of see as residential policies and commercial policies. Typically, some of the decision-making at the commercial sector is different, right? So you're sort of dealing with CFOs who are looking at specific ROIs. In theory, residential customers do that as well, though I don't think it actually plays out in practice to the same level of degree. So when we sort of start thinking about renewable heat for the commercial sector, again, it might vary, but you're really looking at sort of paybacks certainly below 5 years. Many cases, the CFOs or CEOs are looking for paybacks below 3 years. So they have pretty aggressive return on investment requirements. Similarly, you start thinking about sort of split incentive programs or split incentive issues. Are you trying to deal with apartment buildings with renters or sort of commercial leases? How do you sort of address the incentives of both the tenant and the owner in commercial buildings? And so we lay out a number of these issues in the report, sort of the barriers. In many regards, there are sort of comparable issues that both the residential and commercial sector will need to address with some specific nuances, as I just mentioned, for the commercial sector. And then you sort of see how the policy just plays out differently as a result of that. I hope that's helpful in answering the question. If you have sort of anything more specific on that, happy to take a crack at it.
Great, thanks. If anyone has more specific questions, feel free to write them in. We have another question regarding heat metering and the status of heat metering in the U.S. market.
So ASTM and IAPMO, the International Association of Plumbing and Mechanical Officials, have been working together to develop a heat meter standard for the U.S., which could help to guide policymakers in their approach. When I last checked several months ago, the heat meter standard still wasn't complete yet. They've been adapting some European and Canadian standards to the U.S. market. Though I would expect it to be coming out hopefully sometime in the next year or so. Policymakers are also thinking about this. Certainly New Hampshire has been doing some work on how to meter heat appropriately for its RPS, and definitely be worthwhile if you have sort of detailed questions on that to check in with the New Hampshire folks about how they've addressed it. Similarly, Massachusetts has been diving into that as well. And in the Massachusetts case, I think they've sought to simplify the approach for the APS by effectively providing an upfront strip of AICs that can be paid out very early without having to necessarily meter the production to earn the AICs for residential systems. For commercial systems, they would look to meter that and make the payments on a sort of kilowatt-hour thermal production basis. So yeah, a lot of policymakers are sort of considering heat metering, but I think interested folks should start looking at New Hampshire, Massachusetts, and then check in with the folks running the heat meter standard as well.
Great, thanks. Neil, do you know if there is information about the market penetration of air source heat pumps in the commercial sector in Massachusetts or elsewhere?
Great question. I don't have that data at my fingertips, so unfortunately not. I'm sure we could track it down somewhere, though, if we put our minds to it.
Mm-hmm. Okay. And how about efforts to couple policies encouraging air source heat pumps and renewable electricity?
Yeah, that's actually a really interesting question, and one we've just started to think about too. So what's the potential, for example, of combining solar PV with an air source heat pump? Some of the preliminary analysis we've seen have suggested that it's really quite cost effective. And it could be a great deal for a residential owner. So I know a number of policymakers are thinking about this, and I think it's a really interesting line of inquiry that is definitely worth further thought.
And lastly, unless others have more questions, the last question here is, what financing models are being used to move projects to completion? I'm not sure which the attendee is referring to, but perhaps you can give an example of a model being used to move a project forward.
Sure. So I guess off the cuff, there are sort of two approaches that we typically see. One is your typical bank loan. So in Massachusetts, you could apply for the heat loan, 0% financing, to install a renewable heating system and just sort of pay it back, the money you borrow to the bank. On the other hand, there's some of the third-party ownership models we mentioned. And we have seen a number of commercial developers deploying that in New England. And so in that case, the developer comes in, they own the system, and they sell the BTUs to the end user. So there's sort of two very different models, both that have been deployed successfully in the region. There's a host of other financing models that are out there that we could have a very long and detailed conversation on, but perhaps that's a good starting point.
Thank you. Well, that concludes the Q&A part of the webinar, and actually the webinar itself. Neil, thank you again for joining us and presenting this paper. The link to the paper, for those of you listening, was on the last slide. There is also a handouts call-out box in which we have placed a PDF of the report that was just referenced. And if you have any more questions, Neil's contact information is up on the screen. And if you have any questions for me or the Clean Energy States Alliance, you can find us online at CISA.org. We're also on Facebook and on Twitter. You can follow us there, and my email is up on the screen. Thank you, Sam, for organizing us and running the webinar. Have a great day, everyone. Thanks for joining.